So on page 613, it just talks about scatter plots, and we were able to plot those last week. Notice on this graph how there's that little jag. What's this little skip thing mean on that? Because you're going to see that a little bit. Jill? Yes, I love how you said that. It's bigger than the scale. They jump from 0 to 20, and everything else is counting by 4s. So this little jag means that it's bigger than the scale, and they skipped to the part that made sense. So on Khan, when you were talking about making a good scatter plot, you never want your data squished in a spot. That is one way in which we can spread our data out and not have it hard to read, is by using that. So I wanted to point that out because that's not something that we had talked about. I also wanted to talk about the blue box. Positive relationships. We're really good at seeing that it's going up and going down, but it's the verbiage that you need to have for this week. As x increases, y increases. So if this were a distance time graph, as time increases, distance increases. This week you're going to have to plug in your labels. This one would be as time increases, distance decreases. If there's no relationship, you have no obvious pattern. What's not on here is if I go straight across, that means my slope is 0. So the slope tree has all 5 of them, and if it were something that were straight up and down, then that would not be a function. So we went way back to like chapter 5 where we talked about functions. You cannot make rules for undefined things where it's not a function. And if there's no relationship or no pattern, you also can't make equations. We are going to try to make an equation to predict new data. So we're going to create equations. They're linear in nature. Girls, prove to me that that's going to work. And because I've done this a number of times, I know that we're going to have, well, unless something's very odd. I mean, there's always the chance that in real life it's not going to work out the way you want to. There should be a linear relationship. We're hoping it doesn't rain too much this week, and it's not supposed to, because one year it rained so much that it was dangerous to go in, and we had to make up a different one to do. Okay? So we're hoping that we will be doing the sediment again, and there will be a relationship. Yeah, one year it rained a ton the week before we went, but that day was gorgeous, but the water was moving so fast that my husband couldn't get the sediment samples. We were worried about him floating away, and that would be no good. So we actually had to totally make up a new lab that morning because we couldn't safely do what we had planned. Sometimes that happens. Today what's going to happen is we are going to turn now to page 619. What's going to happen now is last week we talked about lines of best fit and can I get it, and you guys became great by the end of that lesson. If that paper did not get turned in the bin, I am looking at it and you will get credit for doing that. Notice I have the laptop cards, so if you need time to finish that up because you didn't get a chance to do that in Mrs. Bearden's or this weekend, that's something you can do. That's due today. Also, some of you might have time for con today. What we're going to do on our salmon release data is put a line of best fit on there. Notice again, they skipped on both axes here. They skipped from 0 to 1956 and from 0 to 44 here. So anytime you see those jags, you should also use those. Okay, if our data ends up being not zeros, you would create those jags in your data. Okay, what we're going to do is if we have something that's pretty linear, we're going to stick a line on there. Why would we want to stick a line to best fit? What's the point of that at all? Why are we even attempting to do that? And the reason is not because Mrs. Smith says we have to do linear equations in 8th grade. That's not actually why. Why would we want to stick a line on data? What's the point? It's your ticket out the door today, actually, because if you don't know why we're doing it, what do you think, Miss Blair?
Like the range, like the general, like thing, like area that it's in. I'm trying to like.
You're pretty close. But it's not area. This is in general what? This is in general that. It is this. So yes, it's a line, and so it creates a slope. Why do we care? What if I wanted to know 2016? Based on just my dots, can I figure out what the results would be in 2016?
Yeah.
Just based on the dots?
No.
Not exact. If I put the line on there, could I get pretty close? And so the reason, and this is your ticket out the door, the reason we put lines of best fit on scatter plots is so we can predict information that's not there. You're going to predict how big you would expect some things to be based on our scatter plot. We don't know exactly, but mathematically we can get pretty close. Kaylee, what's your question?
What if there's like an outlier?
Now, there were a couple of data points that were outliers, right? You still have to take those in account because they're still there for some reason, even if we don't know what that is. We are not far enough scientifically to be able to find causation. That means find out why things are there. And so if there's an outlier, we'll talk about what that means. If it's really high, that means your line has to go a little higher. If it's really low, your line has to go a little lower because the line of regression measures the distance and creates an area model. And so because that distance would be big, it actually has to slide it up. I could get more complicated, but it's beyond the scope of this class. It's my favorite answer. Just trust me. Outliers, if it's higher, makes the line go a little higher. Lower makes the line go a little lower, but that's why they're measuring distances. They're actually creating area, but it's really kind of what the distance is. Other questions about that so far? Someone tell me, why would we put a line of best fit on a scatter plot then? What's the point? Someone tell me. Kenzie.
To predict information that's not
Say that louder. That was perfect.
there. To predict information that's not there.
Why are we going to put lines of best fit on our scatter plots? Why, Miss Blair?
Predict data that's not there.
Good. Everybody tell me, why are we putting lines of best fit on our scatter plots? To? Oh, that was awful. We're going to try that one more time. That's terrible. I know.
There's literally any of us here.
No, there's still a lot of you here. There's still more of you here than there are in my 7th grade classes. Ready? Why are we going to put lines of best fit? To? That's why. Whew. Okay. So, that was so terrible to start.